All right, slope and forms of linear equations. Right, let's do this one. The slope of a line. Let L stand for a given line in the Cartesian plane, and let x1, y1, and x2, y2 be the coordinate of any two distinct points on L. The slope of L is also the ratio of y2 minus y1 over x2 minus x1, which can be described in words as the change in y over the change in x, or rise over run. You would have seen this one once upon a time as this right here. Remember when we first decided, we said m is equal to slope, which is equal to rise over run, which is equal to y2 minus y sub 1, x sub 2 minus x sub 1. And that just gave us our slope, right? Pretty straightforward on that one. Just remember, and I think I kind of hit this up, notice here, showing these 2 points here for the slopes. This could be my point 1, this could be my point 2, hence the sub 1, sub 2s. But remember that if you really wanted to, it doesn't matter which slope is your first point. Okay, sorry, which point. I could make this my second point and this my first point. The math is always going to work out. So it doesn't matter which point you decide to go with first. The slope is always going to work just fine. Okay? We good with that? Okay, so that's still, like I said, kind of review there. Let's do a quick example here. Notice, I'll give us a couple here. It gives us a little bit of room. Determine the slopes of the lines passing through the pairs in points of r squared. Remember, r squared, don't be freaked out by the terminology. We're calling r squared the Cartesian plane because this is a real and that is a real. Okay, that's why they're calling it r squared. Okay. So determine the points, okay, or determine the slope of those 2 points. So my rule of thumb always is to label them because you know what? I'm really bad about looking at wrong things. So I come right in here and I'm going to go ahead and label this as x1, y1, x sub 2, y sub 2. Now, like I said, does it matter which is your first point, which is your second point? No. You can do this, okay? It doesn't matter. Okay? And that would be your slope. So let's go ahead and put it in our formula here. I've got y2 minus y1 all over x2 minus x1 is equal to, my y2 is going to be a 0. My y1 is going to be, notice I put a minus sign and then I put the negative 21. Because I am substituting a negative for a variable, I'm wrapping that variable in a parenthesis, realizing I am putting a variable in there. Or a negative in there, I apologize. X2 is negative 3, and then I got minus 0. Negative and negative make it positive, so those right there go positive. You can always rewrite if you want to. You've got 0 plus 21 all over negative 3 minus 0. That ends up being 21 divided by negative 3, which in essence, now hear me out, that would be a technical slope. You could actually use that slope, but you're going to, one, get a blue bar because it's going to say, hey, you didn't simplify it. And I'm going to take off a point on your midterm because you didn't simplify it. So 21 divided by 3 is going to end up being negative 7. While that is a slope, remember, slopes are always over 1 if they look just like a regular whole number. Okay? In your homework, I actually do it the other way around. I show you, go, hey, flip them around. Make the second point, make the first point your second point, and it still works out. Okay, you still get the negative 7 when it is all said and done. I apologize. I put that actually, that negative. I didn't. Good. All right. Why don't you try to do the ugly one, and then I will play catch up with you. All we're doing is slope now. Remember y2 minus y1. TV back here for y'all. That's not a valid slope though, right? Still got that fraction inside, right? So remember, you're just gonna end up having 12/1, okay? Divided by 1/4, but we don't divide. 12/1 times what? 4/1, so your slope is actually 48. Or 48/1, 48 will be just fine. So if this was my slope right here, not if, it is, literally, you're saying you're gonna go up 48 points over 1. Up another 48/1. So a pretty extreme slope when it all boils down to it. So. Good there. Okay, it's kind of review, right? So as review happens, let's look at this right here. Horizontal lines, which can be written in the form y equals c, have a slope of 0. Vertical lines, which can be written in the form x is equal to c, have an undefined slope. Please, somebody tell me why. Why would there be an undefined slope when x is equal to c?
Is it because it's not on the y-axis? Like it doesn't, is that the ones that,
You got vertical lines, you got horizontal lines, yes.
so like when the point only crosses,
I think you're thinking of intersections.
Oh, okay.
Okay. Look at it this way. Keep the math very simple. If I show you a horizontal line, okay, so we've got y, we got x. When y is equal to c, we're gonna have some line that just does that, don't we? Can we all agree that no matter what happens with the x value, it's gonna change? The x value is gonna constantly change, right? But the y value is always gonna be the same. So like we had, like, say y is equal to 2. I'm gonna kind of scroll just a little bit so we can kind of see this. If I have y is equal to 2, it's always going to be 2 on that line. But I can have a lot of different points for the x value, okay? So notice when we put this in, if I do 2 minus 2, because that would be my y2 and y1, they would be the same point, okay? And then if I just have any number here, like if I had, like, say for my x, I could have 3 minus 5. Doesn't really matter, right? But notice this becomes 0 over -2, which becomes a 0. That's why there is a slope of 0 there. But the converse is true. If I have x is equal to 2, that would just be another line right here where x is equal to c, which says what? Well, then I could have this. Let me kind of draw a line here. On the top, my y could be almost anything. So we could say 3 minus 5 is on top. But if I said x equals 2, then 2 minus 2, then notice what happens. -2 divided by 0, and what can we never divide by? 0. And so therefore we get that undefined whenever you have a straight up and down, okay, vertical line. So that is why anytime you have x is equal to c, some vertical line, you do not have a defined slope, okay? Continuing on here, we have 2 little things. Now, back in the day, these were shown to you in 2 separate chapters. Now we're just combining them into one. If the equation of a non-vertical line, because if it was vertical, it would be undefined. If the equation of a non-vertical line in x and y is solved for y, the result is an equation in slope-intercept form. The constant m is the slope of the line, and the y-intercept of the line is 0, b. If the variable x does not appear in the equation, the slope is 0 and the equation is simply of the form y equals b. Thus, the graph is a horizontal line. Okay? I really don't like their change in terminology from here to there. So I would almost say y is equal to c there. You can say it that way. But we got to stick with the definition at hand, which is this guy right there. Remember, this guy is your slope. That's your y2 minus y1 all over x2 minus x1. This guy is your what intercept?
Your y-intercept.
Y-intercept. When you have a y-intercept, X is always 0. Remember, y-intercept, the opposite is always the 0. So that's how come it's 0, comma, b, some number. So if it asks for the y-intercept in Hawks or even on your midterm, just make sure to put it as a coordinate point, okay? Because it is a point. It's a point right there on the graph where that line goes across the y-axis. To get something in that form, you're obviously going to need the slope and you're going to need the y-intercept, okay? Well, the only problem is sometimes you don't get those, which is why we have this point slope or point slope form of a line, okay? Point slope form of a line is equated for a line passing through the point. Notice not the y-intercept, just a point, okay? With the slope m, okay, and you got y minus y1 equals mx minus x1. Note that m, x1, and y1 are all constants while x and y are the variables, okay? Note also that since a line by definition has slope in, vertical lines cannot be described in this form, okay? Basically saying it'll still be undefined again, okay? You're going to get something that's undefined. Where do they come up with slope form? It looks something a little bit like this. Make it a little bit larger here so you can kind of see it. I gave you y2 minus y1 is all over x2 minus x1. That equals m, correct? Well, if I want to put this in slope form, now remember, y2 and y1 are 2 points. This is designating I need 2 points. That's to find a slope, you always have to have 2 points. Point slope form says I only need to give you 1 point, but I got to give you a slope. If I don't give you a slope, I've got to give you 2 points so you can still find the slope. Does that make sense? Now notice you can derive the point slope form by saying, hey, how about we get the y by itself again? Which would mean, hey, go ahead and multiply this side and multiply this side. And then look what happens. That cancels out, doesn't it? And then what are you left with? Since I only need 1 point, I can get rid of the y2, and then I can just say, hey, how about y minus y1 is equal to mx minus x1. So it's kind of the way they derive that formula there, okay? They're using the slope to derive a way to find something. So let's see how this works. Remember, you have some forms of lines that you need to kind of remember before we get into the examples. Those are all the different forms of a line, okay? And they tell you what you need to have them, okay? Notice for standard form, basically what they're saying in that first line is this. Hey, to get to that one, either A, I'm going to give it to you, or B, you're going to find it some other way and get it there. Okay, like you'll find point slope form, put it in the formula, get it back to y-intercept, or continue further and get it to standard. And that is usually the progression. Usually you will go from here to here and here to here. Okay, now these two you will use interchangeably. I'm not saying there's never a time. I was really about to say maybe there's a time. No, there's not. You will never go back to point slope form. Point slope form right here is usually the guide that you're going to use to get it to one of the top two. Okay. Notice for point slope form, you have to be given a slope or you need 2 points. No slope, you got to have 2 points. If you don't have 2 points and no slope, you can't do anything. Okay. The only way to go straight to slope intercept form, okay, is to have the y-intercept and the slope. So now hear me out. Hawks is going to be tricky sometimes. It may be saying, hey, how about you go ahead and get this thing into standard form, and they're going to give you 2 points, okay? No slope, but they'll give you 2 points, okay? your gut reaction is going to be wanting to go right down here to slope intercept form, or sorry, point slope form. But if one of your points just happens to be a 0, comma number, you've got a y-intercept sitting inside that point right there. You just need to find your slope and then throw it all together. Okay, so just kind of watch out for that kind of stuff. Okay, not that it doesn't work, it'll still work just fine. It's just going to make you mad when you get to the end and be like, oh, I could have been done faster than this. Okay, so some of the points of math are realizing that there's other ways to get things done a little quicker. We'll skip this first one. This is really, we're just finding slope. Okay, right here. Look at it carefully though. I mean, do you notice anything fishy about this one?
The Y's,
What about them?
they're the same.
So if they're the same, what's going to happen whenever I subtract them from each other?
It's gonna be 0.
Going to get a 0. So what's going to be my slope? 0, because the y's are on top, right? Think about it. If you've got y2 minus y1 all over x2 minus x1, and the first thing I put down is 11 minus 11, does it really matter what's happening in the denominator at that point? No, because 0 divided by anything is automatically going to be 0, which tells me these points are what? On a horizontal line. Okay? Because a slope of 0 is always a horizontal line. Okay? So that's always nice. Well, how about this one right here? Find the equation of the line in slope-intercept form. Slope-intercept form, read your question carefully, that passes through the following point with the given slope. Simplify your answer. Slope-intercept form is what? Y is equal to mx plus b. You probably said it so much now that you got it memorized. Hopefully. Is my point a y-intercept? No, because notice the x value is not a 0. Okay, so nope, I can't just throw this into the formula and just walk away. I've got to use the point slope form and then work it back to the slope intercept form. So my point slope form is y minus y1 is equal to m x minus x sub 1. First things first, go ahead and start plugging in all your stuff. Okay, notice I have a x1, I have a y1, and they give me a slope. So I've got y minus, put in parentheses, 11 equals 8 x minus negative 3. Can rewrite this as y plus 11 is equal to 8 x plus 3. I want to stop there very quickly and just kind of do some little quick review for you. If I told you to graph this, okay, first off, let's just be honest. If I told you to graph it, you could graph that very easily by literally finding that point, negative 311, right? Putting it in, and then what are we going to do? Go up 8 and over 1. There's our point. But what if I just showed you that guy right there? Nothing else. That's it. I want you to start realizing from this point alone, from that little equation, you can go ahead and start graphing from there. You don't need to solve it. Because notice you have a point here, you have a point here. But if you're seeing a positive 11, okay, you actually have to look at it as a what? It's going to be a negative point, because a negative and a negative made that positive. So that's how come you have a negative 11 here. This positive 3 will give you a negative 3 point. I'm saying this, 1, save you some time. 2, this is going to be very important when we get into chapter 3 and 4, mainly 4. When we start taking these graphs that you're used to, and we're going to start moving them around, stretching them and stuff like that, it's really important to realize that when you see a plus, things go negative. When you see negative, things go positive. Okay? And then, of course, we've got the slope right there. So let's do the math on this one very quickly here. We're going to go ahead and distribute that 8. And I've got y plus 11 is equal to 8x plus 24, right? And then we're gonna come in here and say we're gonna subtract 11 from both sides. Right over here, and we're gonna have our final answer. Y is equal to 8x plus, what is that gonna be, 13? What is our y-intercept?
13.
0, not 13. 13 is where? 13 what? 13, it's gotta be 0, 13, right? So yes, it's gonna be 0, 13. And then our slope is, of course, the 8, which we knew walking into that. Okay, it had to be the 8, okay? Any other hard ones here that I give you that are mean? Mhm. No, I think we're, okay, now notice this one. Find the equation of the line and slope intercept form that passes through the following points, simplify the answer. What is the problem with this and what do they not give you?
Slope.
Yeah, they don't give you a slope, so you've got to find the slope first, right? And then pick either point. It doesn't matter which point you pick, you're gonna get the same answer. Matter of fact, I think, yes, in your homework, when you look at your, when I download your notes today, I do it both to prove it to you that no matter what, you get that answer right there. Okay? I'm not gonna work this, but there should be a reason why. If I have a slope of a line right here, I have a point here, I have a point here. This is gonna be my point 1. This is gonna be my point 2. Notice neither one of them are sitting as the y-intercept, just like our deal here. We also do not know the slope, okay, of this, but we can figure it out, okay? Well, the reason both of these work, can anybody tell me why both of those work? Because your answer to this one turns into this. Y is equal to 8 over 7x minus 32 over 7. It becomes like 4/7. Okay? Can someone tell me why? Why is it that whenever I find the slope, if I decide to use 11/8, I get this answer? Or if I decide to use -3, -8, why do I still get the same equation? Shouldn't I get a different one? I'm using different numbers. Shouldn't I get a different answer? Spoiler alert. Aren't they all in the same line? You better have the same equation because that line has the same slope, right? The slope that affects this line, won't it affect that line just as well? Just like it'll affect a point there, just like it affects a point there. It'd be like saying, hey, I'm gonna go climb Everest. Well, while I'm on Everest, it doesn't matter where I'm on Everest, I'm still on Everest. Does that kind of help y'all understand why you have to have the same, it has to work everywhere on that line, okay? Because you've never been off the line. Now, if all of a sudden you decide to pick a point over here and another line, it's not gonna be the same because it's not the same line anymore. Okay, that's why that works. So don't get hung up on just like, what if I pick the wrong point? You're not gonna, can't happen. You can't even put the points in wrong, okay? The only thing that's gonna happen is if you ended up putting these points in different, is this. And this is a good thing to kind of remember. If you made this your x1, if I made this my x1, y1, x2, y2, you're gonna get a point that I believe is probably gonna look like this, like -32 over 7. Well, what if I did this? What if I did x2, y2, And then I did this one as my x1, y1. Well, then you're gonna get one that looks like this. 32 over -7. But it still works because one's saying what? Go down, right? And then go this way. The other, and I don't think I have a point, yeah, either way. But the other one's saying go up and then go back. So you're really just kind of working in this nice little square pattern here. So it works either way. Now, how you're going to see them in your everyday life is going to be negative 32 over 7. We kick that negative out. Okay. A lot of things people do on that one. They get messed up. They get confused about. So it's normal. I get it. How we feeling so far? College job pretty easy so far? More or less, except for that circles. Circles kind of stuck a little bit. Or circles all right? Anybody done your SOCA homework yet? Or you're waiting? All right, let's jump into the next one. Parallel and perpendicular lines. Slopes of parallels. Two non-vertical lines, because they can't be vertical, because if they're vertical, they would be what? Up and down. Can you have vertical lines? They'd be undefined, right? How are you gonna have parallel lines? Okay. But yeah, I guess unless you had two undefined lines, and this will be perfect because it worked. Two non-vertical lines with slopes M1 and M2 are parallel if and only if M1 and M2 equals M2. Also, two vertical lines with two undefined slopes are always parallel to each other, which is what we just kind of derived, right? Slopes of perpendicular lines. The slope of M sub 1 and M sub 2 represents slopes of two lines, neither of which is vertical. The two lines are perpendicular if and only if, just so you know, if you ever hear this, that's called a biconditional statement. If M sub 1 is equal to negative 1 over M sub 2, equivalently, M sub 2 is equal to negative 1 over M sub 1. And if you multiply M1 and M2, it equals negative 1. If one of two perpendicular lines is vertical, the other is horizontal, and the slopes are respectively undefined and 0. That's a lot. Okay. Let me narrow this down for you. Hey, if you're looking at two different equations of a line, notice that M is always going to be a slope for you guys. This is not some arbitrary variable that you're seeing. M is slope. It will always be slope. We will always define it as slope. Okay? So, if I have a line over here that has this slope, M sub 1, and I have another line over here with another slope, totally different line, right? M sub 2. If those slopes are the same, that means I'm looking at it going like, say, y is equal to 2 over 3x, whatever. I look at one over here, y is equal to 2 over 3x plus whatever. Same slope. If you have the same slope, they are parallel. So same slope. That's what that said in a very mathy way. That's what that just said. Slopes of perpendicular lines. You heard this called the negative reciprocal back in the day. Remember that one? What does that mean? Look at it carefully. If I have a slope here, y is equal to 2 over 3x plus 1. You should be able to look at that one and go, I can graph that. That's at the y-intercept of 0, 1. I'm going to go up 2 and over 3. There's my line. I got it graphed. If I want another line that was perpendicular to this one, okay, you multiply it by the negative reciprocal, okay? Which means, reciprocal means do what? Flip it, right? So you take the slope and you flip it. And you make it a negative. Okay? Is that good? Now, don't get hung up on that making it a negative. Okay? There's a reason for this. Because you're multiplying it by a negative. So if we really wanted to be kind of like mathy about this, we would say we would take the reciprocal and multiply it by a -1. So when I took the reciprocal of the slope I just had, right, I flipped it, multiplied it by a -1, and I get -3/2. There would be my new slope that would now be what? Perpendicular to the other line. It's the negative reciprocal. Look what would happen if I had this. How about if I had y is equal to -2/3 x plus 1? Well, once again, I take the reciprocal, right? When I take the reciprocal, I get 3/2. That's a negative. But then I'm multiplying it by a negative. And a negative and a negative make what?
Positive.
So there's my new slope. That makes sense? Because notice what's happening. When you're finding a slope that's perpendicular, you're saying, I am going to make it the most opposite it possibly can be. So I'm going to flip it. And if it's positive, I'm going to make it negative. If it's negative, I'm going to make it positive. It's always going to be completely opposite. And therefore, you will get perpendicular lines out of it. When you play around the math of this, notice how right here it says if you multiply if you multiply those two slopes together, you should get a -1, which does make sense. If I have -2/3 times 3/2, I guess it's a great way to check yourself, right? Notice what's going to happen. Hey, that goes to a 1, that goes to a 1, and then what's my final answer? -1. Isn't that what that said right there? Okay. Good. Let's look at some examples. Consider the following equation. Just jumping straight into some Hawks examples here. Consider the following equation. Express the given equation in slope-intercept form. Simplify your answer. Remember, slope-intercept form, it's always going to be get y alone. Y is equal to mx plus b, so we're going to get y by itself. I'm emphasizing that. That is going to become uber important moving forward in this class, getting y alone. Okay? So we're going to come in here, let's do some math. I'm going to come right in here and go ahead and distribute that guy. Rewrite, I get 3y minus 4 is equal to -10 positive 4x. Am I good there? Come right in here. I'm going to take that 4. I'm going to get that 4 to the other side, right? So how about we add 4 and add 4? That cancels it out over here, and I get 3y is equal to, I think at this point, wouldn't you say, let's go ahead and start getting it in the form we know it should be in, right? Let's move that x closer to that equal sign. So I'm going to put the 4x right here. -10 plus 4 gives me a -6. Divide 3 by every term. That reduces that to a 1. And then we get what? Y is equal to 4/3x minus 2. And there's our answer. Not knowing what they're going to tell you to do later on, sometimes, because like I said, sometimes Hawks does updates. If you were going to put this in standard form of a line, remember that's something of the form ax plus by is equal to c. So you're going to get that constant alone on one side of the equation and then get the variables on the other side. okay? And which you could do from right here. You could start moving everything around, okay? Good. Well, notice this says step 1 of 2. So let's see what it says here on step 2. Step 2, they give us, notice the same thing here. And it says, hey, find the equation of a line which passes through that point right there and is parallel to the given line, what we just solved. Parallel, okay? So we already have this line here that we created, y over 4/3 x minus 2. For another line, another slope, or sorry, another line to have this be parallel, what does the slope need to be?
The same.
The same, because parallel lines always have the same slope, okay? So I know my new line is going to have a slope of 4/3. But I don't have a y-intercept. But that's okay, because in the previous lesson, we were given that point slope form that says, as long as you give me a slope and a point, I can pop it in this equation and out will come what? Y-intercept. Okay, so we're going to plug everything in to our y minus y1 is equal to m x minus x1, and let's go ahead and solve. So we've got a point here with an x and a y value. And I covered up part of that. We have y minus 5 is equal to 4/3 x minus 13. Go ahead and distribute. Now, let me help you out with. Everybody okay if I take a break and show you and make your life a little bit easier? You're gonna see a lot, I mean, on my notes, I show you the math. But here's a good, you can go and you can finish if you'd like. I'm not going to hammer you too much on going, can you do fractions? Can you do fractions? I'm gonna be looking at my notes just so you know, okay? But look at this very carefully. Turn on clear. Notice I'm gonna go to mode. You're gonna have to hit, if you're using mine, okay, or a TI 30XS, okay? Notice down here at the very bottom, I don't have it in classic mode, I have it in math print, okay? Now that I know it's in math print, I want to give you little hints. Watch this. Let's say, let me kind of get somewhere. Real quickly, let's get it to a point that's going to be ugly. Watch this. We come over here, we start doing some math. We get this y minus 5 is equal to 4/3 x minus, okay? That's going to end up being 52/3, right? That's pretty straightforward math. But then notice what I got to do. I got to add 5 to both sides. So that becomes add 5, but I put that as 5/1. Correct? We good to right there? To add those together, I had to find a common denominator, correct? And then put them together. Well, here's what's nice. My numbers here are going to look like this. I'm going to have, now that was a negative 52/3. Look at this little button right there. For some of you who didn't know. Well, watch this. I'm going to go ahead and put my negative in there. 52/3 plus, it again, 5/1. I'm not trying to find a common denominator. Why would I do that? When the calculator will do it for me. Okay, and then when we come back over here and look at our homework, you can look at my final answer here. My final answer is going to be, coming over here, y is equal to 4/3 x minus 37/3. In your notes, I do the math, the step-by-step math. on this video that you can go back and watch later if you go, hold on, you mean we can do that every time? You bet your bottom dollar you can. Okay, now you gotta be careful though. Okay, remember, it's still a calculator. So a calculator is gonna give you the right answer every time of what you put in it. So you start putting in wrong numbers, it's gonna give you the right answer with your wrong numbers. Okay, so be very careful and don't lose the skill of being able to understand fractions. To be honest, on this one, it's usually quicker to go ahead and do it by hand, but that is a method of doing things, is it not? Good on that one? You'll thank me whenever we start. Remember last year when we started doing the quadratic formula? You can put the quadratic formula in there the same way. It'll work out the whole formula and give it to you in fraction form. As long as you don't get a negative in the square root, because at that point you get a domain error, because remember, you can't have negatives and square roots, okay? Let's do some more. Let's do this one that people might get confused on. This one, I went in and actually graphed it in Desmos. I still want you to start getting used to using Desmos, okay? You're gonna really enjoy that one. It is on your Canvas homepage or on your module page. You can click it, go play with it. So it says the following set of four ordered pairs below defines the vertices. Vertices where two lines join, okay? In counterclockwise order of a quadrilateral, a four-sided figure. Okay. It wants us to prove that this is an actual quad. Are these actually parallel? Okay. Is this an actual quadrilateral? Okay. Well, to do that, you got to have all your points, which we do. And so what you're going to have to do for this one is I've got a point here, here, and here. And then notice what I'm going to do. Are the sides parallel? They have to be. For this end to be an actual quadrilateral, all sides have to be parallel to each other. Okay? So you got to come in here and let's go ahead and just start. I'm going to start right here with this negative 6, 6. So you got negative 6, negative 6. And then I've also got going, I'm going to go for this line right here. Okay? That's going to be my negative 8, negative 1. But if I'm looking for something to be parallel, I have to look at what are the 2 points. These over here, correct? So I have to come in here and go, I've got 0, negative 5, and I've got negative 2, 0. Looking at other points, I can come in here and look at this one here, and I'll do some in blue. It's going to give me a negative 8, negative 1, negative 2, 0. And then I'm looking to see, is it parallel to this line here that has negative 6, and 0, negative 5. To be parallel, I'm looking for what? They have to have what slope? Same slope, exactly. So if I came in here and started doing the math of these, notice on this first one here, okay? I'm going to end up having my x1, then black will do x1, y1, x2, y2. I get negative 1 minus negative 6 all over. Sorry, got lost here. Negative 8 minus negative 6. If you'll permit me once again, to make your life a little easier. I'm back over here. Hit my fraction button. And then once again, I'm gonna put negative 1, right? Minus negative 6. And then I have what? Negative 8 minus negative 6. Notice how I'm putting things in parentheses. And there we go, negative 5 over 2. So immediately I could jump right in there and just put it straight in my calculator. Okay. So negative 5/2. And spoiler alert, when you do the next one, you get negative 5/2 as well. Do you have calculators that work this way? Okay, so if you do, you might start trying to use those. Okay. It ends up being that these end up equaling right here, 1/6. So do we have a quadrilateral after that point? Yes, everything's parallel at that point, right? These two are parallel here. And these two are parallel here, and that gives us our quadrilateral. Okay, our four-sided figure. Because if one of them was not parallel, that means at some point they're going to converge. Okay, so you do not have a quadrilateral at that point. Okay. What would you do? This isn't the question, but how would you find, like, say, a square? A square would also have what? It could have parallels, right? Could you also possibly take a line here and a line there and see if they're perpendicular to each other? Think about it. There's a few ways to think about that. Couldn't do it with this one because those lines aren't perpendicular. Remember, perpendicular means it crosses exactly at 90 degrees. Exactly what happens to a square. At that vertice of a square or a rectangle, you would get a perpendicular line, or you could look for two parallel lines. But the problem is, two parallel lines just say this: you have a quadrilateral. Doesn't say you have a square. But if I had perpendicular lines, I could say, oh, look, they're not only parallel, but they're also perpendicular. So notice that could be the definition of a square. Not exactly your exact definition. Some geometry teacher out there is going to hear this one and go, he's technically wrong. Let's do another one. Let's do one more, then we'll call it a day. Look at this one right here. I'm going to show you both sides of this. Notice, step 1 of 3. Express the first equation in slope-intercept form. Simplify your answer. Well, that one looks kind of ugly. But that's okay. Because whenever I have fractions, I want to do what with those fractions? Let's get rid of them. Let's get rid of those fractions. So to get rid of a fraction, all I need to do with this one is, well, first off, let me just give you a little hint. Before you do anything, go ahead and get that thing by itself first. Okay? You don't have to, but man, it makes your life a little easier. Cuts down on some of the math. So notice I have 5 minus 2y minus 2x over 2 is equal to 4x plus 4. Well, how about we subtract 5 from both sides? I'm happy with that. And then I have negative 2y minus 2x over 2 is equal to 4x. 4 minus 5 is equal to -1. How about we come in here and multiply both sides by what?
2.
Yeah, let's multiply both sides by 2. So that way now we don't have to worry about anything anymore. We don't have to worry about the fraction anymore. Notice this fraction is going to reduce out on that side. Do the math to the second side and you're going to be left with, I'm going to come up here so I have more room. Negative 2y minus 2x is equal to 8x minus 2. Now, here's where people are going to mess up. Okay, I know. You know how I know? I did. While doing your homework, I did. And I knew better, but I got quick. I want you to realize I'm going to write a little bit better because my handwriting kind of sucks. This negative is sitting out front. Can we all agree? It's sitting out front. But by removing the 2, by making it go to 1, I have now dropped out the denominator, and that 2, that negative is now moved up. Well, here's the problem with that. If that happens, you need to go ahead and surround that guy right there in parentheses, because now that negative needs to get distributed. Okay? So you come in here and you've got negative 2y plus 2x is equal to 8x minus 2. And now you can finish it up. That would be somewhere where you start getting those red bars, you wouldn't understand it real quick. And it would be something very simple, just like that. Come in here, I'm going to go ahead and subtract 2x from both sides. And then I get negative 2y is equal to 6x minus 2. Divide off the negative 2. And we get y is equal to negative 3x plus 1. That's a lot nicer looking. Express the second equation in slope-intercept form, simplify answer. I'm going to give you the answer to this one. You can look back on the math because that one's, come on, isn't that one pretty straightforward and simple? Okay. When we get done solving this one, we're going to get y is equal to 3x minus 13 over 4. Remember, you have the 12x minus 4y is equal to 13. Just subtract the 12x. Put it in the proper form, negative 4y is equal to negative 12x plus 13. Divide off the negative 4 amongst everything. And then you get your answer there. And then you have step 3, okay? Step 3 says this. Determine if the two lines are perpendicular. Okay, we have two lines here. We have y minus 3x plus 1. Y is equal to negative 3x plus 1. And then we have y is equal to what? 3x minus 13 over 4. Are they perpendicular? One way to check. I know you can just check real quick. Remember this. M1 times M2 has to equal negative 1. Well, negative 3 times 3 is equal to what? Well, that's negative 9. That is not a negative 1. So what can you tell about this? Is it perpendicular? No. Okay. Another way to tell is this. Let's just take this guy here. Remember what you're seeing here. You're seeing m is equal to negative 3 over 1. To find the perpendicular line of that, you would flip it. Remember the negative reciprocal, you would flip it. Okay, well, that becomes 1 over 3, still a negative, and then multiply it by a negative 1, which turns it into 1/3. That would be the perpendicular slope that this guy here would need to be a perpendicular slope. And I can check the math of that because negative 3 over 1 times 1 over 3, notice that will equal negative 1. Okay. And then you can also do the math and show yourself that if you need to find the other one, notice if you had the y equals 3x minus, well, if you needed a perpendicular line to this one, well, that's 3 over 1. Well, how about negative 1 over 3? Wouldn't that be the negative reciprocal to have a perpendicular line for that guy? So, how do we feel about chapter 2? Feeling pretty comfortable so far? Okay. We'll stop there today. We're done.